Good morning, Algebra 2. It is day 7. We are talking about margin of error. So this is probably something you've heard of before, the idea that, a number could be off by a little bit. But this first example, it's kind of fitting for this time of year. It says 89% of high school students want air conditioning. Right? In my mind, it would be 100%, but that's besides the point. So the key here is it says the poll was conducted in June of 2015 at randomly selected New York public high schools. Sample size was 2,500, and the ME, which stands for margin of error, is plus or minus 1.2%. All right. It says we know that the sampling distributions are a method statisticians use to estimate true populations. So like you sample a bunch of people and it should represent everybody without actually surveying the whole population. All right. It says, but how confident are we that our results reflect the true entire population? So it's saying that's where margin of error can help, right? So it kind of gives validity as to how accurate or maybe inaccurate the data could be, all right? So when it says margin of error, a measurement of how accurate our sample is relative to the population, gives us a range of plausible values. That's kind of key there. A range of plausible values for our entire population characteristic based on the sample statistics. So it's saying it should be between these two values, right? So when it says, how can we more accurately estimate this? All right, well, how we're going to do it is we're going to use standard deviation. Right? Because what we've talked about is that we know that 95% of normally distributed data, so when you have the bell curve, falls within 2 standard deviations of the mean. So how you calculate that margin of error is we're going to do plus or minus 2 standard deviations of the mean, or depends on what the data is, to be what we say is 95% confident of our answer. Now, a couple of things. That particular poll, how accurate or inaccurate is it? When it says 89% of high school students, it's only selecting students in New York. It's only selecting public school students. And what do we know about school in New York in June? It's really stinking warm usually. So this could be skewed data. If you ask somebody somewhere else, they might not have the same opinion, or they might hate being cold and they don't want air conditioning. But the idea is you also have to think about this piece of it. But what we're going to look at is, all right, assuming it's unbiased, here's how we give our answer within a certain percentage and feel good about it. So up here, when they said 89%, and then the margin of error is plus or minus 1.2%, they're saying that the real number could really be anywhere between 87.8 and 90.2%, All right, so let's go on so we can show how we actually do some of these calculations and use them. So when it says interpreting margin of error, right here, it's the mean or the proportion. So it depends what type of question you're looking at. And then plus or minus, when it says me, it really means margin of error. All right, so we're not adding you, we're adding and subtracting whatever that little margin of error is. All right, so this will give the interval of plausible values for the actual mean or proportion. All right, because once again, we're trying to estimate what's really going on. So rather than sticking to one set number, we'd say, okay, the actual is probably between these two values, which gives you a little more leeway. Right? So the first example says schools decided that the pacer in PE was getting too boring. They wanted to do a timed mile. Now, if you ask me, these are the fastest kids ever, because I ran yesterday a 10.5-minute mile, and I was like, yeah, it's pretty good. I mean, I know I'm slow, let's be honest, but still. A random sample of 10 11th graders were asked to run the 1 mile, and then they wrote it down. Right? Now, maybe they're trying to run their fastest mile ever. I don't know. In that case, maybe I'd be that kid that's like 9.1, but that's about it. All right, it says find the sample mean using your calculator. So if you remember, if we want the calculator to do the work, we could, of course, add it up ourselves. Otherwise, put everything into list 1 So that means you're going to go to stat and then edit and then put it into list one. Excuse me. And then you're going to go to stat and then calculate, and you're going to have it do one variable stats. This way, you'll get all the information that you would need. All right. So here, I already put mine in here just to save some time. So whatever you have in list one, you can take it out of there. I can zoom in a little bit so you can see a little bit better. Put that information in there, and then I'm going to go to stat and then calculate, and one variable stats is that first choice. So just go to calculate, and then it is going to give you what we need. So X bar is the mean. So they're saying on average for these 10 kids, it took them 7.9 minutes to run that 1 mile. So like I said, they're speed racers. All right. There's the first piece of data. Okay, part B. The school then collected 50 random samples of 10 students and calculated the means. So they just kept taking like different groups of 10, taking their times and averaging them. And it's saying that the standard deviation was 0.6 minutes, so a little bit more than half a minute. It says, based on the standard deviation of the sampling distribution, what is the margin of error? All right, well, for the margin of error, all you have to know is that it's plus or minus 2 of the standard deviations. And now if you want to get fancy, you can do of the X bars because that's of the means, but it doesn't matter. So we're going to go plus or minus 2 times the 0.6, which is going to give us plus or minus 1.2 minutes. That's going to be the margin of error. So what does that mean for us? Well, suppose the mean of the sampling distribution was 7.9 minutes, which that's what we found. Using the margin of error, find the range of plausible values for the actual population mean, right? Because that 7.9 minutes was for that one group here, all right? So if they did the mean of all like the sampling distributions, ended up with about the same thing, all right? What we're saying is that if you then expanded that to every student, well, what would the actual mean come out to be? Well, it should be somewhere between the mean that they came up with and then plus or minus the margin of error, right? So 7.9 plus or minus that 1.2. And so if we do 7.9 minus 1.2, that'll bring us down to 6.7 minutes. If we do 7.9 plus 1.2, that'll bring us up to 9.1 minutes. So they're saying the actual mean should be, oops, sorry about that, somewhere between just shy of 7 minutes and just over 9 minutes, right? The actual mean should be in that range. That's what I mean by a plausible range there, like possible, basically. Like where do we actually think it's going to fall? Somewhere in there, all right? And then when it says interpret the margin of error and the range in the context of the problem, right? We would say that the population mean for the 1 mile run should fall between 6.7 minutes and 9.1 minutes. And then if you want to add to that, you could even say with 95% accuracy. That's why we use the plus or minus 2 standard deviations, because that gathers that middle 95%. Sure, you're going to have groups that are lower times, maybe you're super speedy kids, or groups that are faster times, but the bulk is going to be right in between those 2 times there. So when it says, is a value of 6.8 minutes plausible? All you have to think is it in that range? So because it is, we'd say yes. And all you have to mention when it says why or why not is it is in the range of plausible values. There you go. Okay. So that's what you're giving yourself that set and then asking, is it in the set or not? There you go. All right. Now there are some formulas. You do not have to memorize them. You only just have to know how to apply them, but they would be given to you if you need to use them for a particular problem. All right. So on this next page, it says, what if we're only given one sample instead of a whole sampling distribution? So like we only had that one set of 10 kids and that was it. All right. In that case, the margin of error is still plus or minus 2 standard deviations, right? But to estimate what the standard deviation is, what you would do is you would take the standard deviation, all right, for that set, and then divide it by the square root of the sample size, all right? So this is the standard deviation. This is the sample size, all right? So when you look at this first example and kind of how to use this, it says, suppose students can rate their math class from 1 to 10, 10 being outstanding. All right, a random sample of 10 FHS students produces the following. Calculate the sample means, calculate the standard deviation. Okay, so we're going to go back to the calculator, and we're going to put this into list 1, or you could put it into list 2. I'm going to slide up so that you can kind of see here. So give me a moment here, and I will clear out my list. So we've got 10, 5, 2, 4, 1, 4, 8, 10, 1, and 6. And as always, take a quick look at your list. Make sure it matches. Oh, yep, because I typed in a 40 and I wanted a 10 there. So that would change my data. Okay. Can't give it a 40. Even if you super love math, can't give it a 40. Okay. So once we have those values in there, remember, stat, calculate one variable stats, and then we're going to get the mean. So the mean came out to be 5.1, which makes sense, kind of right in the middle. Not super surprising because some people clearly didn't love math and some people did. All right. Calculate the standard deviation. So the standard deviation here, so the little sigma guy, sorry, is 3.208. All right. And then the next part, it says use the part of the formula above to calculate the approximate standard deviation for the distribution of sample mean size 10. Well, that means that we would take this and say, all right, let's take that 3.208 and divide it by the square root of 10. Right? And that should give us our answer here. I'm just going to check something quick. Okay. All right, so when we calculate that, that should come out to be about 1.014 because it says nearest thousandth, so we're going 3 decimal places. Right? So that's the standard deviation that we're going to use here. Right? So now when it says find the margin of error and we need the standard deviation, that's the guy you're going to use. So it says based on this sample and the range of plausible values, find the margin of error, sorry, and the range of plausible values. So margin of error, let's calculate that first. It's plus or minus 2 times the standard deviation that we just calculated. So it's going to be plus or minus 2 times that 1.014, which is plus or minus 2.028. So when it just says what is the margin of error, they just want that number, the plus or minus that value. All right. Then when it's saying now find the range, now take that and add and subtract that from the mean. All right. So for the range, you're going to do the mean plus or minus the margin of error. Right. So the mean was the 5.1, and then we're going to add or subtract 2.028 to that. So it should bring us down to just over 3.072, and then just over 7.128. That is the range of plausible values. Ooh, sorry. All right, the last part. Is a rating of 8 plausible? Well, look at what we said. We're saying people that like their math class, the typical scores fall between 3 and 7 or whatnot. And now we're not saying that no one can score over an 8. We're saying would the average of 10 kids rating the class come up over 8? And in this case, unfortunately, no. All right, it's not in the range. Right. And so that's what I want to make clear is we're not saying that no one student could, score below a 3 or above a 7. It's the idea that what this represents is if we sampled, another 10 kids or the whole population, right? the mean value would fall in this range. Okay. So when it says, is it plausible? Simply answer yes, if it's in the range. And again, that's the mean plus or minus the margin of error. And then no, if it's not in the range. So that part's pretty simple. So as long as you can calculate it, then it's just, yep, it's in, or nope, it's not. All right. Let's see, the very last page. We'll finish it because we've got it. It's got formulas that we have seen before that, again, I reminded you, you don't have to memorize them. You just have to know how to apply them. All right, that's it. So if you're going to use it, it's going to tell you to use that particular formula. Let me zoom out just a smidge here. All right. So for this one, the margin of error for a sample proportion, it's still the same thing. It's plus or minus 2 of the standard deviations of the little p hats, if you want to get technical, right? And then to calculate the standard deviation would be p times 1 minus p, and then over n, and the square root of that whole thing, where p is the actual proportion, and then n is your sample size. Oops. And now, again, what the heck is, why would we need this formula? This is if we're only given one sample. And you're trying to extrapolate to the whole population. That's when you would need this, all right? So when it says here, the polling agency collected 100 random samples of 50 US adults about their favorite soda, it was found that the mean of the sample proportions is 0.31 that favor Coke, with a standard deviation in their sampling distribution of 100 samples to come out as 0.07. Okay, so this is your mean. Remember that mu means mean. All right, and then here's your standard deviation. All right, so it says based on the standard deviation, what is the margin of error for their sample proportion estimate? Okay, don't overthink it. Margin of error plus or minus 2 times the standard deviation. If you want to put the little p hat guy in there, awesome. All right, zoom in so you can see that a little bit better. I wish the view was a little clearer, but it's not. All right, so plus or minus 2 times that 0.07 comes out to be plus or minus 1 point, or excuse me, not 1.4, 0.14. Let me fix that there. So 0.14, that is the margin of error. All right, what is the plausible range of values for the study? We know how to do this. Take the mean, add or subtract the margin of error. So the mean was the 0.31 plus or minus 0.14, right? That brings us down to 0.17 and up to 0.45, all right? So minus here, plus there, of course, right? When it says interpret in context, this is the range of values that the plausible value of people that prefer Coke would fall between. So it's actually somewhere between 0.17 and 0.45. Like that's the reasonable answers you'd expect, right? So this is the range of plausible, I'm going to say, proportion of people who prefer Coke. Now, I don't know what they prefer Coke to. I guess like all other sodas. I'm not reading into this too much. Last part, is a proportion of 0.41 plausible? So all you need to ask yourself is it in the range? The answer is yes, it is. Therefore, yes, it's plausible. All right. It's in the interval. You got it. Okay. Last question. It saying in a sample survey, 50 people were randomly asked about their favorite soda. Excuse me, 38% of them listed Coke as their favorite. Okay. Based on the sample proportion P equaling 0.38, what is the standard deviation of a sample of this size? So this one is where you need that formula. So this time we didn't need the formula because they were doing 100 random samples. But when you're doing one random sample, this is where those formulas come in. So you might even want to draw like a big old arrow going from up there down to here, because this is where we have one sample and where we would actually use this. Okay. So in this case, we're going to calculate this guy by doing the square root. They said that the proportion is 0.38. So if P is 0.38, then the 1 minus P, that would come out to be, and there's 1 minus 0.38, 0.62, I want to say, but right now I don't trust my mental math. Oh, yay. It's right. Okay. So it's going to be 0.38 and then times 0.62, and then all over. They asked 50 people. That's your n value. So we're going to put 50 there. All right. So when we calculate that, it comes out to be about 0.069. So that's the standard deviation for that one particular sample there. Okay. And so margin of error would be plus or minus 2 of those standard deviations, those 0.69. So that comes out to be plus or minus 0.138. So when it says, what's the margin of error? First things first, that's that. And then what would be an acceptable range of values for the population proportion? All right, so now you're trying to extend from that one sample to the whole population. Well, that would be the mean plus or minus that margin of error. So when we take the mean of 0.38 and then we add or subtract 0.138, we come out with anywhere from 0.242 to 0.518 as saying where the mean should fall for the actual population proportion that, you know, listed Coke as their favorite. All right, there you go. So the big takeaway, margin of error, plus or minus 2 standard deviations. If they throw you a funky little formula, use it, but those formulas are only for when you have one sample instead of multiple samples, and you should always be provided the formula. The homework might reference like the formula from the notes, but otherwise, like on a test, you're only going to use that formula if that formula is given to you.